Have you ever wondered why the delicate film of a soap bubble holds together, shimmering with iridescent colors, before vanishing into the quiet air? Have you ever paused to watch a drop of water cling perfectly to the tip of a leaf, defying gravity for just a fleeting moment, held in place by an invisible, gentle force? We walk through our lives surrounded by these tiny, quiet miracles of physics, often without realizing that the very same principles governing a fragile drop of morning dew might just hold the key to the greatest mystery of the cosmos. The universe is a vast, endless sea of darkness and ancient light, a place where our minds often struggle to comprehend the sheer scale of existence. We are taught to imagine space as an infinite, boundless void, stretching out forever in every possible direction, without edge, without shape, without limit. But what if that perception is an illusion born from the limitations of our small, rocky vantage point? What if the infinite expanse we see when we look up at the night sky is not a limitless void, but the curved, shimmering interior of a cosmic bubble? Before we dive deeper into this quiet journey of cosmic discovery, I would like to gently welcome you. I am Theodore, the researcher, your guide through the profound mysteries of our universe. I have noticed that 71% of the beautiful minds who watch our journeys have not yet subscribed to the channel. If you find peace and wonder in these contemplations, please consider subscribing. It helps us immensely and ensures that we can continue to explore the endless silence of the cosmos together. Now, let us return to the gentle dark of space, where the James Webb Space Telescope has been turning its golden mirrors toward the very dawn of time. For most of human history, we assumed our little corner of existence was everything there was. We thought our galaxy, a beautiful, swirling collection of stars, gas, and dust, was the entire universe. When you look up at the night sky from a dark, quiet location, that hazy band of light stretching overhead is actually the combined glow of billions upon billions of distant stars in our own galaxy. Ancient people thought it looked like spilled milk across the heavens, which is where the name Milky Way comes from. Different cultures had different explanations for that beautiful band of light. People throughout history have looked up at that same band of light and wondered what it might be, feeling a deep, quiet sense of awe. It was not until the first telescopes were turned toward the Milky Way in the 17th century that observers began to realize that the milky glow resolved into countless individual stars. They were too faint and too numerous to see with the naked eye, but visible through the magnifying power of glass lenses. This was the first gentle hint that our home was far larger and contained far more stars than anyone had ever dared to imagine. Yet, even then, the true, staggering vastness of the universe remained hidden from us, wrapped in the silent dark. The revelation that shattered our small, comfortable view of reality came in the 1920s, when an astronomer named Edwin Hubble proved that those fuzzy smudges people had been seeing through telescopes were actually entire galaxies themselves. Each one was an island universe of stars in its own right, each one impossibly far away from us, containing billions of their own stars. That singular discovery changed everything we thought we knew about our humble place in the cosmos. The universe was vastly larger than anyone had imagined, filled with countless galaxies. Today, we estimate that there are around 2 trillion galaxies in the observable universe. The numbers become so exquisitely large that they gently stop meaning anything to our human brains. We are adrift in an ocean of galaxies, a cosmic web of structure that challenges our deepest intuitions. But Hubble did not just find that the universe was unimaginably vast. He found that it was moving. He discovered that the distant galaxies were receding from us, rushing away into the ancient dark. The universe was expanding. Space itself was stretching, pulling the galaxies along with it, like dots painted on the surface of an inflating balloon. This was a profoundly unsettling realization. If the universe is expanding, what is it expanding into? Does it have a boundary? Does it have a shape? Is there a surface to reality itself? For a long time, we sought comfort in the idea that the expansion of the universe was a gentle, decelerating breath. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. This made intuitive sense to our grounded minds. Everything in the universe is pulling on everything else through the quiet, tireless force of gravity. You would naturally expect all that gravitational attraction to act like a gentle brake, gradually slowing the massive expansion that began with the Big Bang. But the universe, in its infinite mystery, loves to surprise us. In 1998, two independent teams of astronomers made a shocking, reality-bending discovery. They were measuring the expansion rate of the universe by observing distant supernovas, using them as brilliant cosmic beacons to calculate unfathomable distances. What they found was completely unexpected. The universe was not slowing down. It was speeding up. Distant galaxies were moving away from us faster than closer ones, and the rate of expansion was accelerating over time. But as more delicate data came in from more supernovas and from other quiet observations, the profound result held up against all scrutiny. Something unseen, something immense, was pushing the universe apart, counteracting gravity and causing space itself to expand at an ever-increasing rate. Scientists named this mysterious force dark energy. Though the name tells us very little about what it actually is, we know that dark energy makes up about 68% of all the energy in the known universe. We know that it acts as a kind of anti-gravity, a gentle but relentless pressure pushing space apart rather than pulling it tightly together. We know that its effects become more dominant, more undeniably important over the vast stretches of cosmic time as the universe expands and ordinary matter becomes more spread out and isolated. But we still do not know what dark energy is made of, where it comes from, or why it possesses the exact delicate strength that it does. It might be a fundamental property of empty space itself, a concept called the cosmological constant that Albert Einstein once proposed, and then famously called his biggest blunder, or, as recent awe-inspiring observations from the James Webb Space Telescope are beginning to hint, it might be something even more strange, even more beautiful. The James Webb Space Telescope has been observing distant galaxies with unprecedented sensitivity in infrared light, peering through the cosmic dust to the very dawn of creation. And within those impossibly deep, quiet images, anomalies are beginning to emerge. The distribution of matter, the way light bends and stretches across the unimaginable voids, is whispering a new secret. Some theoretical physicists are beginning to ask a question that sounds like pure poetry. What if dark energy is not just a repulsive force, but a form of cosmic surface tension? What if our universe is a multidimensional bubble, and dark energy is the tension of the film that separates our reality from whatever lies beyond? Imagine again that fragile soap bubble, resting for a fleeting second on the tip of a child's finger. The surface of the bubble is in a constant state of delicate tension, an intricate balance of molecular forces pulling against each other to maintain its shape. If you were a microscopic being, living entirely within the impossibly thin film of that bubble, you would not perceive the air inside or the air outside. Your entire observable reality would be a two-dimensional universe, stretching out in a curved, closed loop. You would feel the tension of your universe as an intrinsic property of empty space, a force that dictates how your reality behaves, how it expands, how it holds itself together. Could we be living in exactly such a state? Are the three dimensions of space we move through, and the fourth dimension of time we flow along, simply the shimmering surface of a cosmic bubble expanding through a higher dimensional void? In a very real sense, we are archaeologists of the cosmos, studying the ancient past rather than the present. Every observation of a distant object is a quiet look back in time, a gentle glimpse of how things used to be rather than how they are now. And as we gaze further, the question remains, are we seeing an infinite expanse or just the curve of a beautiful, fragile bubble? Let us pause for a moment and think about the instrument that is whispering these profound new secrets to us from the endless dark. The James Webb Space Telescope is not merely a machine constructed of beryllium, gold, and glass. It is the physical, tangible manifestation of human wonder. It is a golden eye floating more than 1,000,000 miles away from our warm, blue, and bustling world. It rests in a region of space called the second Lagrange point, a quiet, gravitationally stable place where the pulls of the Earth and the Sun perfectly balance the orbital motion of the spacecraft. Out there, in the profound, freezing silence of the solar system, it deploys a massive, kite-shaped sun shield to block out the light and heat of our home, keeping its delicate, ultra-sensitive instruments unimaginably cold. It must be cold because it is designed to see the universe's heat. It is designed to capture the ancient infrared light that has been traveling toward us since the very beginning of everything we know. When we look through the golden mirrors of James Webb, we are not seeing the universe as it exists today. We are seeing ghosts. We are looking deep, deep into the past. As the late, great astronomer Carl Sagan once profoundly noted, we are like butterflies who flutter for a day and think it is forever. Our human lives are so brief compared to the cosmic time scales. Yet, we have built an instrument that allows us to look back across billions of years. Light travels at an incredibly fast yet finite speed. It takes time for the light from a distant star to reach our eyes. When you look at the sun setting on the horizon, you are seeing it as it was 8 minutes ago. When you look at the nearest star system to our own, Alpha Centauri, you are seeing it as it was over 4 years ago. But when the James Webb Space Telescope looks at the most distant galaxies at the edge of the observable universe, it is capturing photons that have been journeying through the silent dark for over 13 billion years. These ancient, exhausted photons left their home when the universe was just a newborn, before the Earth existed, before our sun was even a thought in a collapsing, swirling cloud of primordial gas. Over those billions of years of silent, quiet travel, something profound and beautiful happens to this light. As the universe expands, it stretches the very fabric of space itself, and as space stretches, it stretches the light traveling through it. Visible light emitted by those early fierce stars is stretched out over eons, its wavelength lengthening until it drops out of the visible spectrum entirely and becomes invisible infrared radiation. This phenomenon, known as cosmological redshift, is exactly why we needed a telescope like James Webb. But in capturing these ancient whispers from the dawn of time, we have stumbled upon a mystery that is currently shaking the very foundations of modern cosmology. It is a mystery known to scientists as the Hubble tension, and it is a beautiful, confounding paradox that challenges everything we thought we understood about the cosmos. To understand this tension, we must think about how we measure the vastness of the expanding universe. Astronomers have two primary, completely independent ways to measure the rate at which the universe is stretching outward. One way is to look at the very early universe, studying the faint, ancient afterglow of the Big Bang itself, an omnipresent glow called the cosmic microwave background. By analyzing the tiny fluctuations in this ancient light, we can use our standard models of physics to predict exactly how fast the universe should be expanding today. The other way to measure the expansion is to look at the local, modern universe, measuring the distances and speeds of nearby galaxies using pulsating stars and exploding supernovas as standard cosmic candles. For decades, scientists comfortably assumed these two entirely different methods would eventually give us the exact same number, converging on a single, beautiful, elegant truth about the cosmos. But they do not. The local universe, the space relatively close to our own Milky Way, appears to be expanding significantly faster than the ancient universe predicts it should be. The numbers stubbornly refuse to agree. This is not a mere rounding error. This is not a simple mistake in the calibration of our delicate instruments. As our measurements have become more and more precise over the years, the gap between these two numbers has only widened, becoming an undeniable, glaring contradiction in our understanding of reality. It is as if we are trying to measure the flow of a quiet, gentle river, and we find that the water is inexplicably moving at two entirely different speeds at the exact same time, completely defying the laws of fluid dynamics. For a long time, physicists held on to the hope that better data, clearer images, and sharper instruments would eventually resolve this tension, naturally smoothing out the wrinkles in our theories. But the James Webb Space Telescope, with its flawless, uncompromising vision, has recently confirmed the measurements of the local universe. The tension is real. The universe is behaving in a way that our current models simply cannot explain. And this brings us gently back to our shimmering, fragile bubble. How does the concept of surface tension in a soap bubble relate to the tearing of the cosmic fabric and the mystery of the Hubble tension? When you blow a bubble on a quiet afternoon, the soapy film is thickest and most relaxed at the very beginning of its life. As it expands and catches the breeze, the material stretches thinner and thinner. The physics governing that delicate film change subtly depending on its thickness and the curvature of its surface. If the universe is indeed a bubble expanding into a higher dimensional space, the dark energy driving its expansion might not be a constant, unwavering force as we have long assumed. Instead, it might be a dynamic, evolving property of the cosmic film itself. Imagine that the tension of our universal bubble is changing as it grows older and larger. In the early universe, when the cosmic bubble was smaller and the fabric of reality was, metaphorically speaking, thicker and more tightly bound, the tension behaved one way. This early state gives us the slower expansion rate we measure from the ancient light of the cosmic microwave background. But today, billions of years later, our cosmic bubble has expanded enormously. The fabric of our reality has been stretched across an unimaginable volume of space. What if the surface tension of the universe has shifted simply because the bubble is now stretched so impossibly thin? This would mean that dark energy is not a static property of empty space, but a changing force, a physical manifestation of the universe's surface. struggling to maintain its integrity as it swells into the infinite dark. The renowned astrophysicist Neil deGrasse Tyson often gently reminds us that the universe is under no obligation to make sense to us. We bring our small terrestrial intuitions, shaped by our lives on a tiny rock, to the study of the cosmos, expecting the universe to behave like the familiar objects we can hold in our hands. But the cosmos operates on a scale and a level of complexity that humbles us, demanding that we expand our minds to encompass new, radical possibilities. The idea that we are living on the membrane of an expanding bubble is one such radical, beautiful possibility. It suggests that our three-dimensional reality is just a thin, shimmering slice of a much grander, multidimensional architecture that we cannot yet see. If we are indeed drifting on the surface of a cosmic bubble, it forces us to ask profound questions about what lies inside the bubble and what lies outside in the vast unseen. Are there other bubbles floating in this higher dimensional bulk? Is our universe just one single, shimmering sphere in a vast, endless foam of multiverses, each with its own unique laws of physics, its own quiet mysteries, its own delicate surface tension? Every ancient photon we capture is a tiny piece of a puzzle that is larger than time itself. The Hubble tension, this frustrating, beautiful paradox, is not a failure of science. It is a doorway to a new understanding. It is the universe gently tapping us on the shoulder, whispering that there is more to the story, that the mystery is deeper and more profound than we had ever dared to dream. Ignorance, in the face of such vastness, is not something to be feared or ashamed of. It is the very engine of our curiosity. It is the reason we build golden mirrors and send them into the freezing void. As you rest and contemplate these enormous, reality-bending concepts, remember that you are an integral part of this bubble. The same forces that govern the expansion of the cosmos, the same ancient laws that dictate the tension of reality, are the exact same forces that allowed the atoms in your body to form. You are not separate from this grand, quiet mystery. You are the universe experiencing itself, a momentary awakening of consciousness on the surface of an expanding sphere. Feel the gentle stillness of the present moment, knowing that you are moving through the cosmos at incredible speeds, carried along by the stretching fabric of space. The mystery of the bubble is not something to cause anxiety. It is something to inspire a deep, lasting peace. We are held safely within a structure of unimaginable scale and beauty, a structure that is still generously revealing its secrets to those who are patient enough to listen to the silence. In the next part of our quiet journey, we will look closer at the specific, mind-bending anomalies James Webb has found in the deepest regions of space, the strange, ancient galaxies that should not exist according to our current models, and how they might be the very ripples on the surface of our cosmic bubble. We will explore how the concept of a curved, bounded reality might finally unite the seemingly incompatible worlds of the very small and the very large, bringing a new, beautiful harmony to our understanding of the universe. Let us resume our quiet journey into the ancient depths of the cosmos. Imagine floating in the absolute silence of the interstellar void, far removed from the bustling noise of daily life, surrounded by the infinite dark waiting to reveal its secrets. When astronomers first pointed the James Webb Space Telescope at a seemingly empty patch of sky, a region near the constellation of Ursa Major, they expected to find the faint, scattered remnants of the very first stars. They expected to see a slow, gradual assembly of matter, tiny fragments of gas and dust tentatively coming together under the gentle pull of gravity. According to our long-held models of cosmic evolution, Building a massive galaxy takes time. It is a slow, meticulous process requiring billions of years of cosmic history, countless mergers, and the patient accumulation of material. But the universe, in its infinite wonder and mystery, offered us a reality far more astonishing than our theories. In those deep, quiet images, captured in the invisible infrared light that has journeyed for over 13 billion years, James Webb revealed something impossible. It found galaxies, not small, irregular clumps of nascent stars, but massive, fully formed, brilliantly glowing galaxies existing just 500 million years after the Big Bang. Before we delve deeper into this impossible discovery, I would like to pause and gently welcome you. I am Theodore, the researcher, your companion on this quiet journey through the vastness of space. I have noticed that 71% of the beautiful, curious minds who watch our explorations have not yet subscribed to the channel. If you are finding peace and wonder in these cosmic contemplations, please consider subscribing. It helps us immensely and allows us to continue unraveling the quiet mysteries of the universe together. Now, let us return to those ancient, impossible galaxies gleaming in the cosmic dawn. To understand why these galaxies are so shocking, we must think about the delicate recipe of creation. In the standard model of cosmology, the early universe was a hot, dense, and remarkably uniform soup of particles. As it expanded and cooled, tiny microscopic fluctuations, quantum ripples born in the first fraction of a second, began to grow. Gravity, the quiet architect of the cosmos, took hold of these slightly denser regions, slowly pulling more and more hydrogen and helium gas together. This process, known as hierarchical structure formation, dictates that small things must form first. Tiny dwarf galaxies containing perhaps a few million stars should be the only structures present in that ancient epoch. They would eventually collide and merge over billions of years to form the majestic, sprawling spiral and elliptical galaxies we see in our local universe today. But the James Webb Space Telescope looked back to an era when the universe was only 3% of its current age, and it found behemoths. It found galaxies containing tens of billions of stars, galaxies as massive and mature as our own Milky Way, existing at a time when the universe had barely taken its first breath. How could such massive structures assemble themselves so quickly? The timeline of reality appears to be broken. This is where our beautiful, elegant concept of the cosmic bubble gently returns to offer a potential mind-bending solution. If the universe is not a flat, infinite expanse, but the curved, taut surface of an expanding bubble, the rules of early cosmic evolution might have been entirely different. Think about the surface tension of a soap bubble once more. When the bubble is very small, just beginning to inflate from the wand, the surface tension is incredibly strong. The curvature is sharp, and the physical forces binding the film together are tightly compressed. If our universe began as a tiny, fiercely expanding bubble, the fabric of space-time itself would have been subjected to an intense, primordial surface tension. In this environment, the standard, gentle rules of gravity might have been amplified or altered by the geometry of the bubble itself. The extreme curvature and tension could have acted as a cosmic catalyst, forcing matter to clump together at an astonishingly accelerated rate. Imagine ripples traveling across the surface of a quiet pond. If the pond is vast and still, the ripples spread slowly, gently dissipating over the wide expanse. But if you have a tiny, highly pressurized sphere of water, any vibration or ripple on its surface is magnified, interacting intensely with itself. The microscopic quantum fluctuations in the early universe, those tiny irregularities in the distribution of matter, were the initial ripples on our cosmic bubble. In a flat universe, gravity alone would need billions of years to turn those ripples into massive galaxies. But on the surface of a small, tightly curved, rapidly expanding bubble, the extreme tension might have squeezed those ripples, rapidly collapsing enormous clouds of pristine hydrogen gas directly into supermassive black holes and billions of brilliant ancient stars. The impossible galaxies discovered by James Webb might simply be the natural consequence of matter being caught in the intense, dynamic surface tension of the young universe. They are the magnificent scars of our universe's violent, beautiful birth, preserved in ancient light for us to find in the quiet dark. This elegant idea brings us to one of the most profound intersections in all of science, the meeting point between the very large and the very small. For a century, physics has been divided into two separate, incredibly successful, yet completely incompatible realms. We have general relativity, Albert Einstein's masterpiece, which describes the universe on a vast cosmic scale. It tells us how gravity gently curves space and time, orchestrating the majestic dance of planets, stars, and galaxies. Then we have quantum mechanics, the strange, counterintuitive framework that governs the microscopic world of atoms, electrons, and subatomic particles. For decades, brilliant minds have tried and failed to unite these two realms into a single theory of quantum gravity. They simply refuse to speak the same mathematical language. But the surface of a bubble possesses a unique property. It has a thickness. Even the thinnest, most delicate soap bubble has a microscopic thickness composed of individual molecules of water and soap sliding past one another. What if the film of our cosmic bubble also has a fundamental thickness? In higher dimensional physics, our entire observable reality is often described as a cosmic membrane, and it is not infinitely thin. Its thickness would be determined by the fundamental microscopic constraints of quantum mechanics. If you were to zoom in close enough to the very fabric of space-time, past the scales of stars and planets, past the molecules and atoms, down to the unimaginably tiny Planck length, space would no longer look smooth and continuous. It would look like a boiling, chaotic foam, a quantum foam where tiny, transient bubbles of space and time are constantly popping into and out of existence. The surface tension of our grand cosmic bubble is, therefore, generated by the collective, seething energy of this microscopic quantum foam. The macroscopic expansion of the universe, driven by the mysterious dark energy, is intimately, inevitably, linked to the microscopic quantum fields that make up the very thickness of reality. The very large and the very small are holding hands, whispering to each other across the cosmic scale. The ancient galaxies are not an error in our models. They are a profound clue. They are inviting us to let go of our rigid, flat assumptions and embrace a reality that is curved, dynamic, and wonderfully complex. They remind us that the cosmos is not a static museum of dead stars, but a living, breathing entity, stretching and evolving in ways we are only just beginning to comprehend. As we sit here, safe on our quiet world, wrapped in the thin atmosphere protecting us from the infinite void, it is natural to feel incredibly small. But smallness is not insignificance. Humility before the unknown transforms ignorance into a gentle motivation to learn. We are the universe's way of thinking about itself. Our minds, though housed in temporary bodies, are capable of reaching out across 13 billion years to touch the dawn of time. We can conceptualize the surface tension of reality, finding peace in the realization that we belong to a beautiful mystery that defies simple explanation. The cosmos does not demand perfect understanding. It invites us to witness its majesty with respectful wonder. In our next chapter, we will explore the fate of this cosmic bubble. If it is inflating, will it eventually pop? Will the surface tension tear, or will it expand forever into the endless silence? We will look at what the ancient light tells us about the ultimate destiny of all things, finding comfort in the profound endurance of our universe. Let us close our eyes for a moment and envision the gentle stretching of reality. We have spoken of the origin of our cosmic bubble, of the intense primordial surface tension that may have squeezed matter into those brilliant ancient galaxies discovered by the James Webb Space Telescope. But as we sit quietly under the vast ancient canopy of the night sky, a natural question arises, a whisper in the silence of our minds. If the universe is a bubble, inflating endlessly into the higher dimensions of the unknown, what is its ultimate destiny? Will this fragile sphere of space and time eventually reach a limit and pop, tearing the fabric of existence in a sudden, violent end? Or will it continue to stretch forever, its surface becoming so unimaginably thin that the cosmos simply fades into an eternal, quiet dark? To answer this, we must look at the forces currently dictating the expansion of our universe and the evidence written in the light of the most distant stars. For most of the 20th century, astronomers believed that the expansion of the universe was slowing down. They thought the quiet, tireless pull of gravity would act as a gentle brake, gradually slowing the expansion that began with the Big Bang. But as we have discovered, space itself is expanding, and not just expanding, but accelerating in its expansion. This acceleration is driven by the mysterious force we call dark energy, which acts as a kind of anti-gravity, pushing space apart rather than pulling it together. Before we project our minds trillions of years into the distant future, I would like to gently pause and welcome you. I am Theodore, the researcher, your dedicated guide through the profound mysteries of our universe. I have noticed that 71% of the beautiful, curious minds who watch our journeys have not yet subscribed to the channel. If you are finding peace and a sense of wonder in these cosmic contemplations, please consider subscribing. It helps us immensely and ensures that we can continue to explore the endless silence of the cosmos together. Now, let us return to the fate of our expanding bubble and the long, slow twilight of reality. As space expands faster and faster, distant objects recede from us at ever-increasing speeds. There is a limit to how fast light can travel, but there is no limit to how far space itself can expand. Because of this relentless stretching, driven by the tension of dark energy, eventually, objects will be carried away from us by the expansion of space faster than their light can travel toward us. When that profound moment arrives, they will vanish behind a cosmic horizon, forever beyond our reach. Imagine standing on the surface of our expanding bubble. The neighboring galaxies, once visible as beautiful, glowing islands in the dark, are being carried away as the rubber of the balloon stretches. Over billions of years, the night sky will slowly begin to empty. One by one, distant galaxy clusters will fade from view, their light no longer able to reach across the expanding void. The observable universe, which currently contains about 2 trillion galaxies, will shrink and shrink. This means that the universe will become an isolated, lonely place, a quiet giant floating in an ever-emptying void, watching as one by one The other galaxies fade from view, but our bubble does not pop. There is no catastrophic rupture of space-time. Instead, the universe is slowly winding down toward heat death. The physics of our bubble dictate a much more majestic, melancholy, and incredibly gentle end. Over the next 100 trillion years, the stars that illuminate our galaxies will slowly burn out. The massive blue stars went long ago, exploding as supernovas or collapsing into black holes. The middle-sized stars, much like our own sun, will puff up into red giants, shed their outer layers as beautiful nebulas, and then fade away as white dwarfs. Even the smallest, longest-lived stars, the red dwarfs that burn their fuel so slowly they can shine for trillions of years, will eventually exhaust their hydrogen and go dark. In a universe with 100 trillion stars, there are untold numbers of red dwarfs. These tiny dim stars will be the last to go out. For trillions of years after the larger stars have died, the red dwarfs will continue to burn, providing the only light in an otherwise darkening galaxy. But eventually, even they will exhaust their hydrogen fuel and fade into darkness. By that incredibly distant time, scientists estimate that star formation in the universe will effectively cease in about 100 trillion years. The gas and dust needed to make new stars will have been used up or dispersed too thinly to collapse. No new stars will be born to replace the ones that have died, and the era of starlight will be over. The bubble of our universe will have stretched so wide, its surface tension pulled so unbelievably thin, that the matter within it can no longer gather together to spark the fires of fusion. The universe at this stage will be a dark place, but not an empty one. It will be a ghost of its former self, populated by the corpses of stars rather than by living, burning suns. White dwarfs will slowly cool until they become black dwarfs, objects that no longer emit any light at all. This cooling process takes an almost inconceivable amount of time, perhaps about 1,000,000 billion years. That is roughly 100,000 times longer than the current age of the universe. And what of the supermassive black holes, those gravity-dense anchors at the centers of galaxies? Even they are not eternal. The black holes will slowly evaporate through a process called Hawking radiation. The brilliant physicist Stephen Hawking discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. In the strange world of quantum physics, particle pairs are constantly popping into existence and then annihilating each other. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. Over immense spans of time, this process drains energy from the black hole, causing it to shrink. For a supermassive black hole containing 50 billion solar masses, the time it takes to evaporate is staggeringly long, perhaps something like 10 to the 100th power years, a number known as a Google years. To write out that number in full would require more paper than exists on Earth. It is a span of time so vast that everything we have discussed so far, from the Big Bang to the death of the last stars, is not even a rounding error by comparison. Eventually, trillions upon trillions upon trillions of years from now, even the supermassive black holes will have radiated away their last bit of energy and disappeared from the universe in a final burst of Hawking radiation. When that finally happens, there will be nothing left of the galaxies at all, just the particles and radiation spreading out through an ever-expanding, ever-cooling, ever-darkening universe. The bubble of reality will have become a thin, cold, infinitely stretched film of elementary particles floating in absolute silence. The largest structures we have ever found will have followed the same ultimate path as every other structure in the cosmos, dissolving into the endless night. This vision of the future might seem bleak, but there is something strangely beautiful about it. Our universe will not die in a violent catastrophe. It will simply exhale, entering a state of permanent, undisturbed meditation. It teaches us a profound lesson about our own existence. We exist right now in this brief moment of cosmic history when stars still shine and galaxies still glow. The era of stars and galaxies is just a passing phase, a brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. We are lucky enough to exist during this flowering. We are lucky enough to have evolved intelligence, built telescopes, and pointed them at the sky. Let this sink in as you breathe deeply and feel the weight of your own existence. Every atom in your body was forged in the fiery core of an ancient star that died so that you could live. The universe is a vast, ancient entity, but it is not separate from you. You are made of star stuff. You are the universe looking at itself, trying to understand what it is and how it came to be. In all the vast history of the universe, stretching from the Big Bang to the final heat, death, this moment, right now, is special. It is the moment when the universe has developed the ability to look at itself and wonder. When we think about the infinite scale of the cosmos, the trillions of years that lie ahead, and the endless silence that awaits, it does not diminish our lives. Instead, it elevates them. It reminds us that our consciousness is a rare, beautiful flame burning in the deep dark. We are part of the universe observing itself from within. The fact that human beings living on a small rocky planet orbiting an ordinary star in an unremarkable part of an average spiral galaxy have somehow developed the ability to understand objects so far away that their light left before a complex life existed on Earth is nothing short of a miracle. In a universe of mindless matter and energy, of particles bouncing around according to physical laws, somehow here on Earth, consciousness has emerged. Minds that can wonder, question, investigate, and learn. The journey of discovery is an infinite one, and we are just taking our very first gentle steps. As our bubble expands, stretching the fabric of space and carrying the galaxies away, we stand here on our tiny world, reaching out with our minds to touch the very edge of reality. We measure the surface tension of the cosmos. We count the ancient photons falling into our golden mirrors, and we build a map of eternity. If the universe can produce such wonders, what else might it be capable of? What other mysteries exist out there in the vast dark that we have not yet discovered? The understanding of the cosmos belongs to humanity as a whole, a shared heritage of knowledge that transcends any single person. As we prepare to delve further into the physics of this expanding bubble and the implications for parallel universes and the multiverse theory in our upcoming chapters, let us rest in the peace of knowing that we are part of something magnificent. We are the cosmos awake. We are the universe experiencing its own grand, quiet journey. The darkness is not empty. It is full of ancient light and endless potential. Embrace the mystery. Let the vastness calm your mind, and know that you belong to this infinite, gentle universe. Every breath you take is a testament to the incredible journey of matter and energy over billions of years. You are a child of the stars, a living, breathing piece of the cosmic puzzle, and your ability to comprehend this vastness is the greatest wonder of all. Let the silence of space wrap around you like a comforting blanket, and let the gentle rhythm of your breathing align with the slow, eternal expansion of the universe. As we gaze into the dark, we are not looking into an abyss, but into a mirror reflecting our own deepest origins. The stars that have faded, the galaxies that have drifted beyond the horizon, they all played a part in the grand orchestration of reality that allowed us to be here, asking these profound questions. The quiet journey continues, and with every step, we grow more connected to the boundless cosmos. Have you ever stood by the ocean on a quiet, fog-heavy morning, staring out at the water, and wondered what lies beyond the veil of the mist? You can hear the gentle rhythm of the waves. You can feel the damp, ancient chill in the air. But your eyes can only see so far before the world fades into an impenetrable gray. Our cosmic perspective is very much like standing on that foggy shore. We look out into the deep, infinite dark of space, mapping the galaxies and measuring the expansion of our cosmic bubble. But eventually, we reach a limit. We reach the cosmic horizon, the point beyond which light has simply not had enough time to reach us since the dawn of creation. But what lies beyond that boundary? If our universe, with its billions of galaxies and its stretching fabric of space-time, is indeed a delicate, inflating bubble governed by surface tension, we must inevitably ask the most profound, unsettling question of all. What is our bubble expanding into? What is the ocean of mist that surrounds our shimmering drop of reality? To approach this question, we must leave behind the familiar three dimensions of our everyday experience and step gently into the realm of the multiverse, a concept so vast it challenges the very limits of human imagination. Before we venture beyond the edge of our known reality, I want to gently welcome you once more. I am Theodore, the researcher, your companion on this quiet journey through the infinite. I have noticed that 71% of the beautiful, curious minds who watch our explorations have not yet subscribed to the channel. If you are finding peace and wonder in these cosmic contemplations, please consider subscribing. It helps us immensely and ensures that we can continue to unwrap the quiet mysteries of the cosmos together. Now, let us cast our minds out into the unseen depths, beyond the curved surface of our universe. Theoretical physicists, those quiet architects of mathematical reality, have a name for the space that exists outside our cosmic bubble. They call it the bulk. Imagine, if you will, a vast higher dimensional space, a realm possessing perhaps 10 or 11 spatial dimensions, most of which are folded up so tightly we cannot perceive them. Within this incomprehensibly vast bulk, our universe, everything we have ever seen, every star that has ever burned, every galaxy we have ever mapped, is merely a single, three-dimensional membrane floating in the silent dark. We are trapped on the surface of this membrane, unable to move into the higher dimensions, just as a drawing on a piece of paper cannot suddenly lift itself off the page and float into the room. This concept, born from the rigorous mathematics of string theory and M-theory, suggests that the infinite void we see is only infinite from our restricted perspective. From the viewpoint of the bulk, our universe is finite, a beautiful, self-contained sphere of physical laws and ancient light. But if the bulk exists, is it empty? Nature rarely creates an endless ocean just to house a single drop of water. If the laws of quantum mechanics and cosmic inflation allowed for the spontaneous creation of our cosmic bubble, then those same laws should allow for the creation of others. This is the quiet, staggering foundation of the multiverse theory. Imagine not just one soap bubble floating in the breeze, but a vast, frothing sea of cosmic foam. In this grand architecture, our universe is just one among an infinite, uncountable number of other universes, each one a separate, independent bubble inflating within the higher dimensional bulk. The scale of this idea is so enormous that it gently breaks the human mind. If our single universe contains 2 trillion galaxies, each with hundreds of billions of stars, the concept of multiple universes introduces a scale of existence that stops meaning anything to our intuition. It is a mathematical infinity made real, a testament to the boundless creativity of the cosmos. What would these other bubbles look like? Would they be filled with stars and galaxies like our own? The mathematics suggest something even more wondrous, because each bubble universe might have been born from a different microscopic quantum fluctuation. The fundamental laws of physics within each bubble could be entirely different. The surface tension of reality, the strength of gravity, the mass of an electron, the very nature of light. All of these could vary from one cosmic bubble to the next. In some universes, the expansion might be so fierce and rapid that matter never has the chance to gently coalesce into stars. They would be dark, empty voids expanding forever. In other universes, gravity might be so overwhelmingly strong that the bubble collapses back in on itself moments after it is born, crushing everything into a singular point before life could ever begin. But in a multiverse of infinite possibilities, there would also be countless bubbles where the delicate balance is struck, where the laws of physics are perfectly tuned to allow for the slow, beautiful evolution of complex chemistry, stars, planets, and perhaps consciousness. Is this all just beautiful mathematical poetry? Or is there any physical evidence that we share the bulk with other cosmic bubbles? As scientists meticulously scan the ancient light of the cosmic microwave background, the fading afterglow of the Big Bang itself, they look for anomalies, tiny variations in temperature that might hold the secrets of our origins. And they have found something strange, a quiet mystery hidden in the oldest light in the universe. It is called the cold spot, a massive region of space in the direction of the constellation Eridanus that is inexplicably cooler than the surrounding cosmos. It is so large and so anomalously cold that our standard models of cosmic evolution struggle to explain it. Some brilliant, daring cosmologists have proposed a breathtaking hypothesis. What if the cold spot is a bruise? What if, in the incredibly distant past, during the fierce early expansion of the multiverse, another cosmic bubble gently bumped into our own? This higher dimensional collision would not have destroyed our universe, but it would have left a mark, an energetic imprint, on the surface of our reality that we now perceive as a vast, quiet, cold spot in the cosmic microwave background. To imagine another universe colliding with ours is to confront a scale of violence and majesty that we cannot truly grasp. Yet, the evidence we see is quiet, ancient, and still. The universe is a master of hiding its most violent processes behind a veil of immense time and distance. If there are other universes out there floating in the bulk, we will likely never be able to reach them. The surface tension of our bubble holds us in, and the vast higher dimensional distances between the bubbles are insurmountable. We are separated from our cosmic siblings by an impenetrable wall of physics. But there is a profound peace to be found in this isolation. We do not need to visit these other universes to marvel at the fact that they might exist. The mere possibility that our cosmos is part of a much grander, infinite tapestry of reality should fill us with a quiet, respectful wonder. It strips away our terrestrial arrogance and replaces it with a gentle, liberating humility. We are not the center of creation, We are simply a beautiful, fleeting pattern on the surface of one tiny bubble in a boundless sea of foam. Let us take a moment to breathe and let these vast concepts settle into our minds. We often worry about the small, daily frictions of our lives, the temporary conflicts that seem so incredibly important. But when you lift your perspective, when you visualize the cosmic foam and the infinite bubbles expanding in the quiet dark, those terrestrial worries gently dissolve. You are a conscious being, woven from the stardust of this particular bubble, endowed with the magnificent ability to contemplate the whole. The atoms in your blood are governed by the specific, delicate laws of physics that perfectly crystallized within our universe. You are an exquisite manifestation of this exact cosmic environment. There may be infinite versions of reality, but this beautiful, quiet universe is yours. We cannot hear the other universes. The bulk is an absolute, perfect silence. But we can listen to the ancient whispers of our own home, measuring the stretching surface tension of our reality to describe the infinite. This is the quiet nobility of the scientific journey, embracing the mystery with an open, peaceful mind. As you rest, let your thoughts drift out past the planets to the very edge of the bubble. Let the silence of the cosmos calm your spirit. In the next chapter, we will look backward to the very first moments of the bubble's creation, the gentle but fierce fraction of a second when time and space themselves were born from the absolute nothingness. Let us take a moment to quiet our minds and turn our gaze away from the distant, fading future of our cosmic bubble, and instead look backward. We have journeyed out to the very edge of the cosmic horizon, contemplating the vast, silent bulk and the infinite sea of the multiverse. Now, we must travel in the opposite direction, peeling back the layers of ancient light, past the fading embers of dying stars, past the impossible galaxies glowing fiercely in the cosmic dawn, all the way back to the ultimate threshold of reality. We are traveling back to the very first moments of existence, to the incredibly brief, fiercely beautiful fraction of a second when our universe was born. When we try to imagine the beginning of everything, our human minds naturally search for a familiar reference point. We think of a seed sprouting in the dark earth, or a quiet sunrise gently pushing away the night. But the birth of our universe was not an event that happened within space or time. It was the violent, magnificent unfolding of space and time themselves. Before this moment, the concepts of before, where, and when simply did not exist. It is a boundary that defies our everyday intuition, a threshold of absolute mystery where the laws of physics, as we comfortably understand them today, gently begin to break down and surrender to the infinite unknown. Before we step across this profound threshold into the primordial fires of creation, I want to take a brief moment to gently welcome you. I am Theodore, the researcher, your dedicated guide through these vast and quiet mysteries of the cosmos. I have noticed that 71% of the curious, beautiful minds who join us on these journeys have not yet subscribed to the channel. If you are finding peace, comfort, and a sense of wonder in these explorations of the infinite, please consider subscribing. It helps us immensely and ensures that we can continue to unwrap the profound secrets of the universe together, building a quiet community of cosmic explorers. Now, let us return to the very edge of time, to the silent spark that ignited our reality. To understand how our cosmic bubble came to be, we must return to the concept of the bulk, that vast, higher dimensional space where countless universes might float like foam. Theoretical physicists suggest that this bulk is not entirely empty. Rather, it is permeated by underlying quantum fields, oceans of potential energy that are constantly simmering with microscopic activity. Imagine a perfectly still, quiet lake high in the mountains. The water is smooth as glass, seemingly frozen in time. But at a microscopic level, the molecules of water are constantly vibrating, shifting, and dancing in a state of quantum restlessness. In cosmology, scientists describe a similar state called a false vacuum. A false vacuum is a region of space that appears perfectly stable and empty, but it actually contains an enormous amount of pent-up, hidden energy. It is like a heavy boulder resting precariously in a small dip on the side of a steep mountain. It is stable for the moment, completely quiet and motionless, but it is not in its lowest possible energy state. If given just a tiny, gentle push, the boulder will roll out of the dip and crash down the mountain, releasing a tremendous amount of kinetic energy. The bulk, prior to the birth of our universe, might have been existing in just such a false vacuum state, a quiet, tense reservoir of infinite potential waiting for a spark in the strange, counterintuitive world of quantum mechanics. A gentle push is not always required to start the boulder rolling. Due to a phenomenon known as quantum tunneling, particles can sometimes spontaneously pass through barriers that they theoretically should not have the energy to cross. It is as if the boulder simply vanished from the small dip and instantly reappeared further down the mountain slope, continuing its descent. In the vast, tense ocean of the false vacuum, a similar quantum event can occur. Through a spontaneous, unpredictable fluctuation, a microscopic region of this higher dimensional space can suddenly tunnel into a lower energy state. When this happens, a tiny, fiercely concentrated bubble of true vacuum is born. This is the exact moment of genesis for our universe. Our entire cosmos, with its 2 trillion galaxies, its 100 trillion stars, and its unfathomable expanses of dark space, began as a subatomic bubble spontaneously appearing in the primordial bulk. It was an event of incomprehensible smallness, a quiet quantum whisper that contained the blueprint for everything that would ever exist. The moment this microscopic bubble of reality formed, it did not simply sit still. Because the false vacuum outside the bubble contained vastly more energy than the true vacuum inside, the boundary between the two states, the very surface tension of our newborn universe, experienced an immense, outward-pushing pressure. What followed was an era of cosmic history known as inflation. In a fraction of a second so unimaginably small that writing it out requires a decimal point, followed by 35 zeros and a 1, our tiny cosmic bubble expanded at a terrifying exponential rate. It stretched from a size smaller than a single proton to something roughly the size of a grapefruit. And then it just kept going. The fabric of space itself was tearing outward faster than the speed of light. This was not the gentle, steady expansion we observe today. This was a fierce, violent stretching that smoothed out the curvature of the bubble, stretching the surface tension so incredibly taut that the universe appeared fundamentally flat from any localized perspective. This period of rapid inflation is the beautiful, elegant mechanism that explains why the universe looks so remarkably uniform in every direction we look today. The sheer violence of this initial expansion ironed out any massive irregularities, creating the vast, smooth canvas upon which the galaxies would eventually be painted. Through a process physicists call reheating, the empty, cold void was flooded with a blindingly hot, dense soup of particles and radiation. This is the moment we call the hot Big Bang, the quiet, microscopic bubble transformed into a raging furnace, In this searing environment, temperatures reached billions of degrees, hotter than the core of any star. The fundamental building blocks of matter, quarks, electrons, and photons, were locked in a chaotic dance, constantly colliding and re-emerging in the fierce heat of creation. The universe became an opaque, glowing plasma, a brilliant flash of light filling the entirety of the newly formed cosmic bubble. It is profoundly humbling to realize that the energy released during this gentle but violent phase transition is the exact same energy that surrounds us today. The universe is incredibly conservative. Energy is never truly lost, only transformed. The fierce heat of the reheating phase eventually cooled as the bubble continued its slow, steady expansion. The chaotic dance of particles settled down. Quarks gently combined to form protons and neutrons, and eventually the universe cooled enough for electrons to bind to these nuclei, forming the first atoms of pristine hydrogen and helium. When those first atoms formed, the blinding fog of plasma finally cleared, and the universe became transparent. The first light was free to travel across the vast, expanding dark. That ancient light is what we now detect as the cosmic microwave background, the fading afterglow of our bubble's fiery birth. Every piece of matter you have ever seen, the ground beneath your feet, the pages of the books you read, and the delicate structures of your own body, is constructed from the particles that precipitated out of that primordial fire. In the quiet darkness of the night, when the world around you falls silent, you can almost feel the echo of that ancient expansion. The gentle rhythm of your breathing mirrors the slow stretching of the cosmos. We are all intricately connected to the profound physics of creation. As we prepare to move forward, we will explore what happened after the first light broke free. We will delve into the dark, invisible scaffolding that guided the formation of the stars and galaxies, a mysterious substance that exerts a quiet gravitational pull on everything we see. We will look at dark matter, the unseen architect of our cosmic bubble, and how it gently shaped the magnificent structure we inhabit today. Rest your mind in the vast, ancient peace of the cosmic dawn, knowing your existence was written into the very first moments of space and time. Let us open our eyes to the quiet, invisible forces that gently shape our shimmering reality. After the primordial fires of the hot Big Bang finally cooled, after the first blinding flash of creation faded into the stretching, expanding dark, the cosmic bubble entered a profoundly silent, peaceful period known to astronomers as the cosmic dark ages. For hundreds of millions of years, there were no stars to illuminate the void. The universe was a vast, endlessly expanding ocean of pristine hydrogen and helium gas, bathed in absolute darkness. But if we rely only on the matter we can actually see, the regular atoms that make up our bodies, the rocky planets, and the glowing stars, we encounter a beautiful, perplexing mathematical impossibility. The visible matter in the universe simply does not possess enough gravitational pull to draw itself together into the magnificent, sprawling galaxies we observe today. The expanding bubble of reality was stretching outward so fiercely, driven by the relentless tension of dark energy, that normal matter would have been dispersed too thinly. It would have been carried away on the invisible tide of cosmic expansion before it ever had the chance to compress and ignite the first brilliant stars. There had to be something else, a quiet, unseen architect laying a massive, stable foundation in the absolute dark. The profound realization that we are fundamentally blind to most of our own universe came to us not through a sudden flash of revelation, but through the careful, patient observation of the night sky by a brilliant astronomer named Vera Rubin in the 1970s. She was studying the rotation of majestic spiral galaxies, mapping exactly how fast the stars in their outer, delicate edges were moving around the dense galactic center. According to the foundational laws of gravity, stars positioned much further away from the dense, glowing core of a galaxy should orbit much more slowly than those huddled intimately close to the center. It is the same gentle mechanics we see in our solar system. But when Vera Rubin analyzed the ancient light from these distant island universes, she found something astonishing. The stars at the very edges of the galaxies were moving incredibly fast, rushing through the quiet dark at tremendous speeds that should have flung them completely out into the freezing intergalactic space. The galaxies were spinning so rapidly that the visible matter could not possibly generate enough gravity to hold them together. They should have torn themselves apart eons ago. Yet, there they were, beautiful, stable, and perfectly intact, spinning serenely in the deep. The only logical conclusion, a profound truth that humbles our human senses and challenges our terrestrial arrogance, is that the galaxies are surrounded and completely permeated by vast invisible halos of a mysterious substance we have come to call dark matter. This ghostly material makes up roughly 85% of all the matter in the entire universe. Yet it remains completely invisible to our eyes and to our most sensitive instruments. It does not emit light, it does not absorb light, and it does not reflect light. It is a true phantom, drifting silently through the cosmos, revealing its massive presence only through its gentle, relentless gravitational pull on the normal, luminous matter that we can actually see. If you could somehow switch off your human ability to see light, and instead tune your eyes to see only the pull of gravity, the universe would completely transform before you. You would not see the shining, familiar stars. Instead, you would witness a magnificent, glowing cosmic web stretching across the entire interior surface of our expanding cosmic bubble. This invisible, silent scaffolding is the true builder of the cosmos. During those silent, starless, dark ages, while the normal hydrogen and helium matter was still too hot to collapse under its own weight, the cold, dark matter quietly began to clump together. It gathered steadily in the slightly denser regions of the expanding bubble, forming massive, invisible gravitational wells. These deep, quiet wells of dark gravity acted like inescapable traps in the cosmic landscape. As the universe slowly cooled, the ordinary gas was inexorably drawn into these enormous dark matter halos, sliding down the invisible, frictionless slopes of gravity until it was compressed enough to finally ignite the very first generation of stars. When the James Webb Space Telescope peers back to the dawn of time and captures images of those massive, ancient galaxies existing just 500 million years after the Big Bang, it reveals the immense primordial power of dark matter. The intense surface tension of the young cosmic bubble may have provided the pressure, but it was the vast reserves of dark matter that provided the heavy, invisible anchor. It held the primordial gas together against the fierce outward push of inflation, allowing those majestic islands of light to form in the deep, ancient dark. Today, billions of years after those first lights turned on, this invisible architecture continues to dictate the grand structure of reality itself. The universe is organized into a staggeringly beautiful pattern known as the cosmic web. If you zoom out to the largest possible scales, you see enormous, quiet voids hundreds of millions of light years across, where almost absolutely nothing exists. Between these unimaginably vast emptinesses stretch long, incredibly dense, river-like filaments of dark matter, running like the delicate, glowing threads of a spider's web woven across the infinite night. Where these invisible, heavy filaments intersect, they create massive, dense nodes of overwhelming gravitational attraction. It is precisely within these busy nodes, these dark matter crossroads, that the grandest structures in the entire cosmos are found. The massive galaxy clusters, all bound permanently together in a slow, eternal, majestic gravitational dance. Our own Milky Way is just a tiny, glowing speck resting quietly within one of these invisible, ancient filaments. We are suspended in a grand cosmic web we cannot even see. Guided by ancient forces we are only just beginning to comprehend. There is a profound meditative peace to be found in deeply recognizing and accepting the invisible aspects of our reality. For thousands of years, humanity intuitively believed that we were the main characters in the grand story of creation, composed of the primary substance of reality. But the quiet, unyielding discovery of dark matter gently, beautifully decenters us. We, the Earth, the diverse planets, and all the brilliant, swirling galaxies are merely the shimmering foam riding on the crest of an invisible, massive, dark wave. The normal atoms that make up our bodies belong to a tiny minority of the universe's total ingredients. We are a rare, exquisite anomaly in a cosmos that is completely dominated by unseen forces. This realization should not diminish our sense of importance. Rather, it should immensely magnify the wonder and the miracle of our existence. We are the luminous fraction of a universe that is mostly dark and perfectly silent. We are the universe's unique way of feeling the warmth of the light and asking questions of the dark. Dark matter is very much like the breath of the cosmos. It surrounds our entire galaxy in a massive halo. It passes right through our solar system. And as you sit right now reading these words, billions of dark matter particles are quietly passing completely through your physical body every single second. They move through you unnoticed, interacting so weakly that you will never feel their passage. You are intimately connected to this ancient, invisible architecture in a tangible way. It provides the stable, secure environment absolutely necessary for life to gently evolve, for complex minds to develop over eons, and for human eyes to eventually look up and wonder about the infinite mysteries of the night sky. As we continue to carefully measure the delicate tension of our expanding cosmic bubble and map the intricate threads of the cosmic web, we are inevitably forced to confront the extreme limits of this architecture, where the dark matter gathers most densely, where the visible matter is crushed together with unimaginable force. The universe creates something profoundly mysterious. It creates objects where the very fabric of space and time is pulled so taut that not even a single photon of light can ever hope to escape. In our next chapter, we will travel directly into the very hearts of these ancient galaxies. We will explore the supermassive black holes that firmly anchor the cosmic web, the quiet monsters sitting patiently in the dark, and discover how these points of infinite density might hold the final secrets about our beautiful, fragile universe. Let the quiet realization of the invisible world wash over you, bringing a deep, lasting peace as we confidently continue our journey into the wondrous, endless unknown. Have you ever walked through an ancient, quiet forest at the edge of twilight, feeling the massive, silent weight of the old trees standing guard around you? The cosmos has its own ancient guardians, silent behemoths that sit at the very center of the majestic, swirling islands of light we call galaxies. We have spoken of the invisible, delicate scaffolding of dark matter, the ghostly web that stretches across the vast, expanding interior of our cosmic bubble. But where those massive, invisible threads of dark matter intersect, where the gravitational pull becomes so overwhelmingly concentrated that it warps the very fabric of reality, the universe creates something that defies all human intuition. It creates a region of space where gravity has won the ultimate, quiet victory over light itself. We are journeying now into the profound, absolute dark of the supermassive black hole, the silent anchor of the cosmic web, to understand how these objects of infinite density might hold the ultimate secrets of our delicate, expanding reality. Before we step across the threshold into this absolute dark, I want to gently welcome you. I am Theodore, the researcher, your companion on this quiet journey through the infinite. I have noticed that 71% of the beautiful, curious minds who watch our explorations have not yet subscribed to the channel. If you are finding peace and wonder in these cosmic contemplations, please consider subscribing. It helps us immensely and ensures that we can continue to unwrap the quiet mysteries of the cosmos together. Now, let us return to the heart of the galaxy, where the normal rules of the universe gently fade away. When we think of black holes, our minds often conjure images of violent, cosmic destruction, ravenous monsters indiscriminately tearing apart everything that dares to wander too close. But the truth, written in the quiet mathematics of general relativity and observed through the golden mirrors of our greatest telescopes, is far more elegant and far more mysterious. At the center of almost every large galaxy in the universe, including our own beautiful, swirling Milky Way, sits a supermassive black hole. These are not the small, stellar mass black holes born from the sudden collapse of a single, dying star. These are behemoths containing the mass of millions, or sometimes billions of suns, all compressed into an unimaginably tiny point. To understand how such quiet monsters came to be, we must look back to the fierce, primordial tension of the early cosmic bubble. As the invisible threads of dark matter drew the pristine hydrogen and helium gas together, the pressure at the very center of these intersections became unfathomable. The gas collapsed not just into single stars, but perhaps directly into massive seeds of gravity, collapsing under their own immense weight until the fabric of space-time simply gave way. Over billions of years of silent cosmic history, these seeds grew, gently consuming surrounding gas, wandering stars, and even other black holes during the slow, majestic collisions of ancient galaxies. They became the heavy, silent anchors around which entire galaxies of hundreds of billions of stars quietly revolve. The anatomy of a supermassive black hole is a masterclass in the extreme limits of physics. At the very center lies the singularity, a point of infinite density where all the mass is crushed into a volume of zero. Here, our current understanding of the universe completely breaks down. The elegant equations of Albert Einstein and the strange rules of quantum mechanics collapse into a profound, unresolved paradox. But surrounding this impossible core is a boundary of quiet, terrifying beauty known as the event horizon. The event horizon is not a physical surface you could touch. It is a mathematical sphere, the exact threshold where the escape velocity required to pull away from the black hole exceeds the speed of light. Because absolutely nothing in the universe can travel faster than light, anything that slips quietly across the event horizon is forever lost to the observable universe. It is a one-way door in the fabric of reality. If you were to gently approach this boundary, the physics of such extreme environments would become bizarre and entirely counterintuitive. Time itself would pass differently for you near the event horizon compared to someone watching from far away. A distant observer would see you moving slower and slower as you approached the threshold, your image becoming dimmer and redder until you appeared to completely freeze, fading into the dark. From the outside, you would never seem to actually cross the boundary. But for you, slipping across the event horizon would feel entirely normal, right up until the tidal forces of the singularity began to stretch you into a long, thin strand, a process physicists have playfully but accurately named spaghettification. Yet, despite their reputation as the ultimate absorbers of light, supermassive black holes are responsible for the most blindingly brilliant phenomena in the entire cosmos. This is a beautiful, confounding paradox. When a black hole is actively feeding, drawing in vast amounts of gas and cosmic dust, that material does not simply fall straight in. It spirals inward, forming a massive, incredibly hot structure called an accretion disk. The intense gravitational friction within this disk heats the gas to millions of degrees, causing it to glow with an unimaginable intensity across the entire electromagnetic spectrum. These actively feeding supermassive black holes are known as quasars. A single quasar, powered by a black hole no larger than our solar system, can outshine the combined light of hundreds of billions of stars in its host galaxy. The light from these ancient beacons is so powerful that telescopes like James Webb can see them shining clearly across 13 billion light-years of expanding space. They are the lighthouses of the ancient universe, illuminating the dark, invisible structures of the cosmic web. The immense energy released by these feeding monsters also generates towering, majestic jets of relativistic particles, blasting outward from the poles of the black hole at nearly the speed of light. These powerful jets carve enormous silent cavities in the hot gas surrounding the galaxy, creating a delicate, beautiful feedback loop that gently regulates the birth of new stars. The black hole acts as a cosmic thermostat, a quiet guardian ensuring the galaxy does not exhaust all its star-making fuel too quickly. It is a profound realization that the darkest objects in the universe are the very engines that orchestrate the light. But how do these points of infinite density relate to our grand, shimmering cosmic bubble? If the universe is a delicate, stretching film, then a supermassive black hole might be thought of as a profound dimple, a place where the fabric of reality is pulled so tightly that it threatens to puncture the film entirely. Some daring theoretical physicists have proposed that the singularity inside a black hole is not an end, but a new beginning. They suggest that the intense, infinite pressure at the heart of a black hole might cause a tiny piece of space-time to pinch off from our universe, gently inflating outward into the higher dimensional bulk to form an entirely new, separate cosmic bubble. In this breathtaking vision of reality, our universe is not just one bubble among many. It is a fertile cosmic tree, giving birth to countless baby universes through the silent, dark wombs of its supermassive black holes. And if this is true, then our own universe might have been born from the collapse of a star in some older, unimaginably ancient mother universe. The multiverse would not just be a random sea of disconnected bubbles, but a vast, interconnected family tree of cosmic reality, passing the spark of existence down through the quiet, absolute dark. Let these staggering concepts gently settle into your mind as you breathe in the quiet night. The existence of supermassive black holes teaches us a profound lesson in humility and wonder. We live in a universe that is capable of creating environments so extreme they challenge the very definition of existence, yet so perfectly balanced they allow for the gentle evolution of life and consciousness. You are a conscious observer in this magnificent, frightening, beautiful cosmos. The atoms that make up your body are bound by the same quiet laws of gravity that govern the event horizons of these dark behemoths. We are inextricably linked to the deepest mysteries of the dark. When you look up at a clear night sky, you cannot see the black holes, but you can feel the quiet certainty that they are there, silently anchoring the great, swirling rivers of stars. They are the dark hearts of the cosmic web, beating with a rhythm that spans billions of years. In our next chapter, we will leave the dark hearts of the galaxies and travel into the most empty, desolate regions of the cosmic bubble, the vast, silent voids between the filaments of light. We will explore what happens where there is almost nothing at all, and discover how the absolute emptiness might hold the key to understanding the dark energy that is gently, relentlessly pushing our reality apart. Rest deeply, knowing the universe is holding you safely in its ancient, expanding embrace. Imagine standing in the middle of a vast, unlit desert at the absolute quiet of midnight, where the silence is so profound it almost hums in your ears, and the darkness stretches out endlessly in every direction, unbroken by even the faintest glimmer of a distant, guiding light. In our ongoing journey across the expanding, shimmering bubble of the cosmos, we have spent much of our time marveling at the brilliant structures of light. We have traced the ancient galaxies. We have followed the glowing filaments of the cosmic web, and we have peered into the dark, heavy hearts of the supermassive black holes anchoring their centers. But to truly understand the delicate tension that governs the entirety of our reality, we must eventually leave the comforting glow of the stars and venture into the most desolate, isolated regions of the universe. We must travel into the cosmic voids, those staggering, incomprehensible expanses of absolute emptiness that lie between the shining threads of the galactic web. It is a beautiful, confounding paradox of the cosmos that to understand the mysterious forces pushing our reality apart, we must study the quiet places where almost absolutely nothing exists. Before we drift completely into this silent, ocean-like emptiness, I want to gently welcome you. I am Theodore, the researcher, your companion on this quiet journey through the infinite. I have noticed that 71% of the beautiful, curious minds who watch our explorations have not yet subscribed to the channel. If you are finding peace and wonder in these cosmic contemplations, please consider subscribing. It helps us immensely and ensures that we can continue to unwrap the quiet mysteries of the cosmos together, building a community of gentle explorers. Now, let us leave the bustling, crowded cities of the galaxy clusters and enter the deepest, most profound silence the universe has to offer. When astronomers first began to map the large-scale structure of the universe in the latter half of the 20th century, they expected to find galaxies scattered relatively evenly across the sky, like a gentle, uniform dusting of snow across a vast field. But the universe, always eager to challenge our terrestrial assumptions, revealed a structure that was breathtakingly complex. As we discussed, the cosmos is arranged in a web, but a web is mostly empty space. The holes in this cosmic web are the voids, and their sheer, unfathomable scale challenges everything we thought we knew about the distribution of matter. Let us look at one of the most famous and imposing examples, the Bode's Void, discovered in 1981 This immense spherical region of space is roughly 330 million light-years in diameter. To put that staggering number into perspective, our entire Milky Way galaxy, containing hundreds of billions of stars, is only about 100,000 light-years across. You could fit over 3,000 of our galaxies end-to-end straight across the boat's void. According to our standard models of how matter should be distributed across the universe, a region of space that incredibly vast should contain roughly 10,000 galaxies. It should be a bustling, thriving metropolis of stellar evolution. But when our most sensitive telescopes peered into the profound dark of the Buddha's void, they found almost nothing. To date, astronomers have discovered only about 60 isolated, lonely galaxies drifting in that entire massive expanse. If our own Milky Way galaxy had been located exactly in the center of the Buddha's void, the night sky would have been completely devoid of any other fuzzy, distant smudges of light, and human beings would not have even realized that other galaxies existed in the universe until the 1960s, when our telescopes finally became powerful enough to peer across such a terrifying distance. The isolation of these void galaxies is absolute, a quiet solitude that lasts for billions of years. But why are these voids so important to our understanding of the cosmic bubble? The answer lies in the relentless, invisible war between gravity and dark energy. Inside the dense filaments of the cosmic web and within the heavy clusters of galaxies, the quiet, inward pull of gravity is incredibly strong. It holds the structures together, fighting valiantly against the stretching of space. But inside the cosmic voids, there is virtually no matter, and therefore virtually no gravity. In these desolate, empty regions, dark energy has won an absolute, uncontested victory. The voids are the true, undisputed engines of the universe's expansion. Because there is no gravity to hold space together in these regions, the space inside the voids is expanding faster than the space anywhere else in the cosmos. As these massive spheres of emptiness inflate, they physically push against the surrounding filaments of dark matter and galaxies, packing them tighter and tighter together. The cosmic web we see is not just a structure built by the pull of gravity. It is a delicate architecture sculpted by the relentless outward pressure of the expanding, silent voids. This dynamic behavior gently returns us to the beautiful, poetic concept of surface tension. The tension of our universal bubble is not a passive, static thing. It is a living, breathing force driven by the emptiness itself. The dark energy that constitutes 68% of our reality is most purely expressed in the absolute silence of the voids. When we look at the voids, we are looking directly at the mysterious force that is stretching our cosmic film ever thinner. But here, the physics of our reality offers us another beautiful, mind-bending paradox. We call them voids. We call them empty space. But in the universe, true, absolute emptiness is a physical impossibility. The nothingness is not actually nothing. If you were to take a box, travel deep into the very center of the Buddha's void, and completely empty that box of every single atom, every single photon of light, and perfectly shield it from all radiation, you might think you have created a state of absolute nothingness. But if you look incredibly closely, down to the subatomic scale, the rules of quantum mechanics gently whisper that the box is actually boiling with energy. According to the Heisenberg uncertainty principle, a foundational law of the quantum world, the universe simply does not allow for a state of exactly zero energy. Instead, empty space is a churning, restless ocean of quantum foam. In this silent dark, virtual particles are constantly, spontaneously popping into existence out of the vacuum, existing for an unimaginably brief fraction of a second, and then annihilating each other, vanishing back into the void. This constant simmering activity is called the vacuum energy, and it fills every single cubic inch of the seemingly empty universe. This quantum boiling is not just a theoretical curiosity. It has profound physical consequences for the fate of our cosmic bubble. Many brilliant theoretical physicists believe that this hidden vacuum energy is, in fact, the very source of dark energy. The relentless outward push that is expanding the universe, the pressure that is driving the galaxies apart and creating the massive voids, might simply be the collective microscopic weight of this quantum foam, the tiniest, most ephemeral particles in existence popping into and out of reality in the absolute dark, or the quiet architects dictating the macroscopic fate of a bubble that is tens of billions of light years across. The universe is a beautifully connected circle, where the physics of the unfathomably small perfectly orchestrates the majesty of the unimaginably large. To contemplate the voids is to confront the true scale of our cosmic isolation, but it is also an invitation to find peace in the vastness. When we look up at the night sky, our eyes are naturally drawn to the light, to the twinkling stars and the glowing planets. We are biased toward the matter because we ourselves are made of matter. But the matter is just the fragile, luminous dust caught in the overwhelming architecture of the dark. The silence of the cosmic voids is not an aggressive absence. It is a gentle, permissive presence. It is the canvas upon which the masterpiece of the galaxies is painted. Without the vast, expanding emptiness to separate them, the stars would collapse into an unreadable, chaotic mess. The space between things is what gives those things their beautiful, unique meaning. As you sit reading these words, wrapped in the quiet stillness of the moment, allow yourself to feel a profound connection to that distant, expanding emptiness. The atoms in your body are held perfectly together by the delicate, ancient laws of quantum physics, the very same laws that govern the bubbling vacuum energy in the deepest, most isolated heart of the Boötes void. You are intimately tied to the nothingness. You are a momentary, beautiful concentration of energy and matter, a complex, conscious ripple standing in defiance of the vast, expanding void. The universe has carved out these massive, silent spaces so that small, delicate structures like our solar system can gently evolve over billions of years, protected from the gravitational chaos of a crowded cosmos. The emptiness is not a threat. It is our cosmic sanctuary. In our final chapter, we will complete our grand journey across the infinite. We will zoom back from the edge of the expanding bubble, traversing the cosmic web, diving past the ancient supermassive black holes, and crossing the quiet, starry expanse of the Milky Way to return to our own small, rocky home. We will gather all the profound mysteries we have uncovered, the surface tension of reality, the Hubble tension, the impossible galaxies, and the quantum foam, and we will explore what this incredible, ancient knowledge means for our brief, beautiful human lives. We will find our place in the cosmic story, resting in the peace that comes from understanding the grand, gentle silence of the universe. Close your eyes, listen to the slow rhythm of your breath, and prepare for our final return to the quiet blue world we call home. Let us begin our gentle journey home. We have traveled together to the absolute limits of human imagination, standing on the theoretical edge of our expanding cosmic bubble and looking out into the silent, higher dimensional bulk. We have witnessed the fierce primordial fires of the first moments of creation, traced the invisible, heavy architecture of dark matter, stared into the infinite density of supermassive black holes, and drifted through the profound oceanic silence of the cosmic voids. Now, it is time to turn around and trace our path back through the ancient dark. Imagine yourself gently floating back through the vastness of the Buddha's void, leaving the absolute emptiness behind. You drift back into the glowing, tangled filaments of the cosmic web, surrounded once again by the slow, majestic dance of the galaxy clusters. You glide past thousands of ancient islands of light, each one holding hundreds of billions of stars, until you arrive at our own local neighborhood. You see the Andromeda Galaxy, our nearest giant neighbor, slowly and inevitably moving toward us in a grand cosmic embrace that will take billions of years to complete. And there, shining with a gentle, welcoming light, is our home, the beautiful, swirling spiral of the Milky Way. Before we descend into the familiar, quiet arms of our home galaxy, I want to take this final moment to gently thank you for embarking on this vast journey. I am Theodore, the researcher, and it has been my absolute privilege to be your guide through these infinite mysteries. I noticed that 71% of the beautiful, curious minds who have traveled with us to the very edge of reality have not yet subscribed to the channel. If this journey has brought you a sense of peace, if it has opened your mind to the gentle wonders of the cosmos, please consider subscribing. It helps us immensely and ensures that we can continue to unwrap the profound secrets of the universe together, building a quiet sanctuary of learning and contemplation. Now, let us return to the pale blue dot we call home. As you slip into the Orion arm of the Milky Way, the density of stars gently increases. You pass by brilliant nebulas, the vibrant, glowing nurseries where new stars are taking their first fierce breaths, sculpted by the invisible winds of radiation. You drift past ancient, dying red giants, puffing their outer layers into the cold dark, seeding the galaxy with the heavy elements that make life possible. Finally, you see an ordinary yellow dwarf star burning with a steady, comforting warmth, and orbiting that star, an impossibly fragile, beautiful blue and white sphere suspended in the eternal night. Earth. When you look at our world from the deep silence of space, the scale of our cosmic bubble suddenly feels deeply personal. Every human being who has ever lived, every civilization that has ever risen and gently faded away, every moment of joy, sorrow, discovery, and quiet contemplation has taken place on this tiny, fragile speck of dust. From the perspective of the cosmic voids or the supermassive black holes, the Earth is nothing more than a microscopic anomaly. But from the perspective of meaning, it is absolutely everything. We have spent this journey exploring the idea that our universe might be a bubble, a delicate film of reality expanding through a higher dimensional void, governed by the profound forces of surface tension and quantum foam. It is easy to feel small when confronted with such incomprehensible vastness. The James Webb Space Telescope has shown us that the cosmos is older, more complex, and more deeply strange than we ever dared to imagine. The Hubble tension whispers that our very understanding of the expanding fabric of space-time is incomplete. The impossible ancient galaxies force us to rewrite the history of creation. The invisible weight of dark matter and the absolute emptiness of the voids remind us that we are blind to the majority of existence. Yet, this smallness is not a tragedy. It is the greatest, most beautiful gift the universe could ever bestow upon us. Think about the chain of events that had to unfold with exquisite precision for you to be here, breathing softly in this very moment. The quantum fluctuations in the false vacuum had to spontaneously birth our specific cosmic bubble. The intense surface tension of inflation had to stretch the fabric of reality just enough to create a flat, stable universe, but not so fast that it tore the cosmos apart. The dark matter had to quietly gather, creating the invisible scaffolding that would catch the primordial hydrogen and ignite the first stars. Those stars had to burn, furiously fusing simple elements into the complex carbon, oxygen, and iron that now flow through your veins. They had to die in magnificent supernova explosions, scattering those precious elements across the interstellar dark, so that eventually they could coalesce into a rocky planet orbiting a stable star. The universe has labored for 13 billion years to create the exact conditions necessary for your existence. The cosmic bubble was inflated so that you could breathe. When you realize that you're not separate from the cosmos, but an integral, inseparable expression of it, the fear of the vastness gently dissolves. You are the universe looking out at itself. You are the quantum foam, the dark matter, and the ancient light, organized into a highly complex conscious pattern. The universe does not just exist around you. It exists within you. The same delicate laws of physics that govern the surface tension of our entire cosmic bubble also govern the surface tension of a tiny drop of water clinging to a leaf in your garden. The macrocosm and the microcosm are perfectly, beautifully aligned. By understanding the strange, counterintuitive rules of the infinite, we gain a deeper, more profound appreciation for the fragile beauty of our everyday lives. The cosmos is not an external environment. It is your ultimate home. There is a deep, lasting peace to be found in this cosmic perspective. We often let our minds become consumed by the temporary anxieties of our daily routines, the small conflicts, the artificial urgencies that society places upon us. But when you step back and view your life through the lens of cosmic time, those terrestrial worries gently fade into insignificance. What truly matters is the quiet miracle of conscious experience. What matters is the ability to look up at the night sky and feel a profound sense of awe. What matters is the curiosity that drives us to build golden mirrors, to peer into the ancient dark, and to ask the universe to reveal its secrets. The James Webb Space Telescope did not just find impossible galaxies and cosmic tension. It found a reflection of our own insatiable desire to understand our place in the grand architecture of reality. As we bring this quiet exploration to a gentle close, I invite you to carry this cosmic perspective with you. The next time you step outside on a clear night, take a moment to look up at the stars. Do not just see them as distant points of light, but as ancient fires burning in the deep, silent expanse of our expanding bubble. Remember that you are standing on a tiny, rotating world, drifting through an ocean of invisible dark matter pushed outward by the mysterious breath of dark energy. Remember that the universe is vast beyond human comprehension, but that it is also deeply, intimately yours. You belong to this magnificent mystery. You are a child of the cosmos, born from the stars, endowed with the glorious ability to understand the infinite. The journey of scientific discovery is never truly finished. Every answer we find gently uncovers a dozen new questions. The mystery of the cosmic bubble, the true nature of dark energy, the existence of the multiverse. These are profound puzzles that will occupy the brilliant minds of scientists for generations to come. But we do not need to possess all the answers to find peace in the unknown. The pursuit of knowledge is a continuous, beautiful journey, an eternal dialogue between the human mind and the silent universe. Embrace the mystery. Let the vastness of the cosmos calm your restless spirit, and let the beauty of our fragile, shimmering reality fill your heart with a quiet, lasting joy. Thank you for walking this path with me. Thank you for allowing your mind to expand to the very edges of space and time. Stay curious, stay humble, and never lose your sense of wonder. The universe is a grand, beautiful puzzle, and we have all the time in the world to explore its infinite pieces together. Keep looking up, keep asking questions, and rest deeply in the comforting embrace of the ancient starry night.